Hello, International Math 1 students. This is Mrs. Gillahan again with some RSG homework help. This is Math 1, Task 1.10. And we're actually going to look at problem number 1 in the RSG, which asks us this. For each set of sequences, find the first 5 terms, then compare the growth of arithmetic sequence and the geometric sequence, which grows faster and when. The entire goal of this particular section of your homework is to help you see truly the differences in growth that occur between the arithmetic and the geometric sequence. So let's take a look at our table that they have given us and see what happens. Okay, we have an arithmetic sequence, f of 1 equals 2, which tells us that the first term in the sequence is 2, and we are being told that the common difference, d, equals 3. We also have a geometric sequence that starts at the exact same spot, g of 1 equals 2. And in this case, it's not a common difference of 3, it is a common ratio of 3. And it is our job to complete the table in order to show these differences. So if we have an arithmetic and a geometric column, let's look at what happens at the very beginning. F of 1 equals 2 for the arithmetic sequence, and g of 1 equals 2 for the geometric sequence. These are the two numbers that were given to us in the instructions. Now we look at f of 2 and g of 2, and we notice that for the common difference in the arithmetic, we are asked to add 3. So 2 plus 3, of course, gives us 5. Now, instead of adding 3 on the geometric sequence, we are actually multiplying by 3 because it is a common ratio. So the 2 times 3 gives us 6. At this point, the value of our outputs for our functions are pretty close together. They're only 1 unit apart. But let's see what happens if we have an input value or the third value in each sequence. Look and see what happens there. If you take the previous term of 5 and add 3 to it, like with our common difference, we end up with 8. But over here, our common ratio being 3, we had to take 6 and multiply by 3, and we get an output of 18. And we can see already the difference in growth that is occurring. F of 3 is 8 here, and G of 3 is 18 over here. Those numbers are starting to get further and further apart. So let's look at the next one, F of 4, for both of these functions, both of these sequences. On the arithmetic side, when we add 3 to 8, we end up with an output of 11. And pretty steady growth, we can see that that is happening over there. But when we take 18 times 3, we notice that the fourth term in this sequence of the geometric side is 54. And we see the growth over here is growing very quickly, and the numbers just continue to get further and further apart. Okay, let's go f of 5. If we look at f of 5 over here, and we add 3 to 11, we get an output of 14. But when we have to take 54 times 3, we end up with 162 over here. And notice the growth again. The input value is 5 for both of these sequences. It's the fifth term in each sequence, but we can see that the geometric sequence has a far greater growth pattern, and it actually tends to grow very quickly. All right, so our question to answer, which value will be more, f of 100 or g of 100? And I think that is a pretty obvious answer. We know that g of 100 is going to be rather huge. It will be a ginormous number. F of 100 will be large, but not nearly so large, because we do have that common ratio, which causes the growth to occur very, very quickly and to continue. It's exponential growth is what we call it, and it is just an incredibly fast growth when we're talking about a geometric sequence versus an arithmetic sequence.